Hello and welcome, my name's Ryan, I'm also known as RM2K Dev. Today we're going to be doing a two-dimensional movement system, a four-directional movement RPG type character inside of Unity. We'll be using Mecanim, the animation system, and the state machine to drive all of this. So I'm going to start off by creating a new project. I'm just going to name this one here Unity tutorials / 2D movement. I'm going to set this default. I'm going to set the defaults for two-dimensional, and I'm going to import a package, but you don't necessarily have to do this. I'm just importing the Visual Studio 2013 tools because I use Visual Studio instead of MonoDevelop. Now, Unity set us up with a basic 2D scene in a game. Basically, at the moment, it doesn't do anything. So let's get started by bringing in some assets. Now, I have prepared earlier a sprite, which is just called Healer F. Now, if you have a look at this one, it's just a standard, RPG Maker type sprite. I'm going to show you how we go through the process of importing these, how we go through the process of animating them inside of Unity, and a really nifty way of doing the animations using Mecanim, or Mecanim. So first up, I'm just going to create a new folder, and I'm going to call this player because this is going to store all of our player information. And I'm going to rename this one here to player as well. I just dragged that sprite in there. Where's my rename? I'm not fully used to the Unity IDE yet, but we'll get there shortly. So now this is called player. What we need to do is, this may not already have done this for you, but if you click on it and go into your import settings, you need to make sure that it's set to type of sprite. Now under sprite mode, click this and change this to multiple. Then select sprite editor. This is going to give us the sprite editor where we can split this sprite up into all of the frames that make it work. So in order to do this, click the slice button in the top left of the sprite editor, change the type to grid. I think the grid on this one is 32 by 34. 32 by 34. I think that's my grid. And let me just preview that grid somehow. No, I'm just going to hit slice. There we go. So it's not 34, it could be 36. Yes, there it is. It's 36. So just click slice and then click apply. And you can close this window off now. If you expand the little arrow next to the player in your asset window, you'll see all of the frames that make up this player. Now you'll notice it's extremely blurry. The next thing we need to do is change our filter mode from bilinear to point filtering and select apply, and we should have bilinear, point, apply. Yep, that should be right. We should have a much nicer version of the sprite if we drag that into our game. Yeah, sorry, it's the preview window has the filtering on it still, so that's fine. So the next step I'll get you to do is to select the first 3 frames. So player 0, 1, and 2. These are the 3 frames that will make up our animation. And drag those into the scene view. Once you've done that, it will pop up and tell you to create a new animation. So I'm going to create a new folder. I'm going to call this anim for animations. And I'm going to call this I'm going to call this player moving. Sorry, I'm going to call this player up walking. Now that we've done that for player up walking, let's select the next 3, which are 3, 4, and 5. And this is going to be player right walking. If we drag this into our scene view and go to our anim folder, we can say player right walking. Now we need the next 3, which are the player down walking. If I drag those into the scene as well, we can create a new animation called player down walking. And finally, we drag the final 3 into the scene, and this is going to be called player left walking. Now in doing that, we've created essentially 4 sprites which will be fully animated with those three frames. So the next thing I'm going to do is I'm going to click on my main camera in my hierarchy. I'm going to change the size of this to 2 just to zoom in a little bit more. Actually, I might change it even further than that. I might go to 1. There we go. I'm just going to position these guys or girls in the middle so that you can see them, and then I'm going to run the game and we'll have a look at those. Those are now animating, as you can see. So that was how we get the animations loaded into Unity. There's actually a really cool way of handling the animations. So what we're going to do is I'm going to first open up this anim folder, and I'm going to get rid of the 4 animation controllers here, 0, 3, 6, and 9. They may be named differently for you, but all we're really interested in from that process were these .anim files, because they specify the frames of the animation. The animation controller itself is what Mecanim uses. It's actually basically just the state machine, which drives those animations on the sprite. So I'm going to delete all of those, and then I'm going to create a new one. So I'm going to right click in here, I'm going to select create, and then I'm going to select animation controller, and I'm going to call this player AC for animation controller. Then if you double click on this, it will open up the animator for you. Now the animator is basically a state machine that we can use to transition between different states of movement, and Unity will handle this for us in a really intuitive way. So what I'm going to do is I'm going to add 2 parameters by going down to the bottom left of the animator, clicking the plus button. The first parameter is going to be a float, which is going to be called X. The second parameter will be a float called Y, and the third parameter will be a bool called isWalking. Lowercase I, capital W. Now, with those 3 parameters created, I'm going to right click anywhere inside the animator, and I'm going to create a new blend tree. Now, a blend tree is basically a way of taking multiple parameters, blending them together, and outputting different results based on the parameters that were supplied. So if I double click on the blend tree, it's going to take us into the blend tree editor. And you can see where we are by this base layer and then blend tree. This is a breadcrumb of where we're at. If I clicked on base layer at the top here, it takes us back to the animation controller. And then if I double click on blend tree, it takes us back into the blend tree. Now over in the inspector in the top right hand corner, where it says blend type, you want to change this to 2D freeform Cartesian. Now, if you remember back to your high school math class, Cartesian basically means X and Y coordinates. So 2D freeform Cartesian, and I'm going to change these parameters to X and Y. Now, in doing that, you see we get the 2 sliders to deal with X and Y inside of our blend tree now. This is where we can add states of different actions to different states, if that makes sense, states of the parameters. So over in our inspector again, where it says motion list is empty, I'm going to click the plus button and click add motion field. The first field is going to be -1 in the X and 0 in the Y. And this is going to be used to determine our left state. Now, what I'll do is I'll take our player left walking animation and drag that into our motion, our parameter motion, there it is, for -1. If I click the plus and then add another motion field, then you'll get this little preview to show you the motions that are available. This one's going to be +1, so just 1 and 0 on the Y. And I'll drag the right walking animation into that one. So now you can see we have these 2 states of motion. We've got the left and the right state now. I'm going to add a third state, which is going to be 0 on the X and -1 on the Y. And that is going to be used for our player up animation, I think. Yep, I should be right. And finally, I'm going to add a final motion field. This one is going to be 0 on the X and 1 on the Y. There we go. And this one is going to be player down walking. And if I press enter and apply all of that, what we should get, it might take a second for this blend tree thing to update. There it is. I think you have to, yeah, that should be right. Oh, sorry, I've got this one here wrong. Player walk right should be 1. Sorry, my apologies. There we go. And what you'll end up with is the 4 directions. Now, if you pretend that this is like a gamepad, that's up responds to up, down responds to down, left to left, and right to right. Those up and down ones actually might be the wrong way around, but we'll check that out in the game when we get to it. Now, the way the blend tree works is you supply it an X and a Y coordinate, and the blend tree will be triggering the animation that makes sense for that X and Y coordinate. Now, you see, if I modulate this X slider here to the left, you see that the player left walking line lights up, and that triggers our player left walking animation. However, if I triggered it towards the right, you'll see that it transitions from being selected on the left to nothing selected to being selected on the right. And it's the same for Now this is the same for the Y direction as well. Negative on the Y is player up, and positive on the Y is player walking down. There you go, as you can see. And this makes it really simple to deal with our walking animations, because all we need to do is supply the animation controller the X and Y position that you're trying to move to. So be it, you know, up, down, left, or right. So now we're done with this blend state. Let's go back to our base layer. I'm going to click on that blend tree again, and I'm going to name this one here walking. There we go. Now the next thing I'm going to do is I'm going to duplicate this. So I'm just going to right click, copy, then I'm going to right click and paste. And this one I'm going to name idle. So instead of walking 0, I'm going to name this one idle, because we need an idle state for our player, one where the player is not moving at all. Now, in order to get our idle animations, which we haven't got yet, we can simply select all of our animations for our player and duplicate them by pressing Ctrl D or Command D if you're on a Mac. Then all I need to do is simply rename these, say idle, left walking idle, I'm going to do that now, right walking idle, up walking idle, there we go, simple as that, and create a animation. So we don't create, so we go to the animation window, which you get to by going to window and then selecting animation, which is this one here. One thing I've just realized is we haven't actually set up a player object yet, so let's do that first. Jump back into your scene view, and what we'll do is we'll delete three of these players that we don't need, because we don't need all of them, we only need the one. I'm going to keep this one here for now. I'm going to place her in the center, and I'm just going to rename this object, right click rename to just player. That will become our prefab later for the player. Now that we have a player that has an animator on it, we deleted all of the animation controllers earlier, so we need to replace the controller in our animator component with the animation controller that we've just been working on. So I'm just going to drag the player AC into the controller for the animator. That will tie this state machine that we've just been working on to that player. If we play the game right now, what you'll see is that they pick a default direction and animate in that direction. If we look at our animator, you'll see that since this is the default state, they will be animating probably to the left. Nothing's tied in yet, so it's not going to update, but we'll work on that in just a second. So from this point, now we have a player which is tied to this animation controller. If you open up your animation window by selecting Window Animation, and then you can dock that anywhere you like in your Unity project. I'm just going to dock it here for now. What you'll see is now we have this this checkbox over here, which allows us to select these different animations. Now the ones that have been assigned to the player currently are left walking, right walking, up walking, and down walking. However, we want to be able to edit these idle states. Now, in order to do that, we need to assign those into our animation controller. So if you go back to your animation controller, go back to the base layer, and then you see that we have the idle state and the walking state. This time, if we open up this idle state, which is a blend tree, we can replace these animations here with the idle versions of the animations. And we do that simply by clicking on the blend tree and then replacing the left walking with left idle. We replace the right walking with right idle. We replace the up walking with up idle, and finally the down walking with down idle, just simply by dragging those onto that. Now, just by doing that, our player object, which has the animator attached to it, which is tied to the animation controller, will allow us to access those new idle states in our animation panel when the game object is selected. If we had any other game object selected, it would be a totally different set of animations, and there are no clips on this object, and therefore there isn't anything to animate. So since we have the animator on the player, we get the different what are they called, animation clips for this object. So now you've got the idle states on here. We need to modify these a little bit. So if you just select left idle, you'll notice that the middle frame there is the idle frame, and the third frame and the first frame are the walking animations. So if we just delete both of those frames and drag this one back to the start, then our player will have an idle animation. I'm going to do the same for the right and the up, and finally the down. And in doing that, we have now created our idle animations. Now I'm going to go back to game view just so we can see what's happening. And then I'm going to go back to our animator. Back in our base layer, our animator for the animation controller, if that makes sense. I hope this makes sense. Now, this is walking property we created earlier. We need a way to go from being in an idle state to being in an animated state. And the way we do this is by transitioning between these blend trees. So first of all, I'm going to right click on idle. I'm going to select it first so it's blue. Then I'll right click on it and select set as default. This makes it orange. Anything that's orange inside the animator is the default animation state. So if I were to run the game right now, it would be default like this. And the other thing I need to do is make sure that we uncheck the record button on our animation. That would create so many problems later if we didn't do that. So now if I hit play and that's default, then what you'll see is the player is just idle animating to the left. Nothing magical is happening yet. But now what we can do is right click on idle and select make transition, and we get this little, I don't know what you call it, this little thing. I'm going to drag that down to walking, and I'm going to make a transition from idle to walking. You see the arrow represents this direction. Then I'm going to right click on the walking and make a transition back to idle. So we can essentially move from this idle state to the walking state, and then from the walking state back to the idle state. Now we can click on these transition markers, I suppose that's what I'll call them, and you'll see we can adjust some properties for this. So what I'll do is I'll click on the first one, from idle to walking. Now the condition, if you look at our inspector, the condition for this to happen is that walking is set to true. Now in our script, what we'll do is we'll tell the animation controller, hey, the player is now walking, set that to true, and then the animation controller will go, one of our conditions is met. I'm going to transition from the idle state into the walking state. On the flip side of that, we need to go back from the walking state to the idle state if walking is set to false, i.e. we're not moving, or we've taken our hands off the controller and no buttons are pressed. And that will basically be the start of our transition system there. Now the next thing we're going to do is jump back into scene view, and I'm going to click on the player again to open up the inspector on our player. Then I'm going to go into the player folder, and I'm going to right click and select create C# script. This is going to be called player movement. And this is the script that we'll be using to direct the player's input system and to take control of that animation system as well. Now I'll be using Microsoft Visual Studio for this, but if you double click on the player movement file, what you'll get is mono-develop. The IDE that you use doesn't particularly matter in this circumstance. So I'm just going to resize this so that we can see it. I'm going to zoom up for you guys so that you can read what I'm working on. Actually, you know what? I'll make this full screen and I'll zoom real close in for you. Okay, now that we've created our player movement script, we simply drag this onto our player in the hierarchy. And then you'll see that just click on the player to confirm that the script has been attached to this game object. And in my case, it has. Then go back to mono develop, and we're going to begin our code for this. So the first thing we need is a private variable to reference the animation controller which is attached to this object. So I'm going to call this anim. So I'll simply say private. Actually, no, I won't say private. I'll just say animation controller, animation. Actually, I think that's what it's called. Let me check what the component's called first. The component is Animator. There we go. So that's what we need. Animator. There we go. And I'm going to call this anim. And at the moment, it's not going to be equal to anything, but it's a private variable. It's local to this scope. Now, in our start function, we're going to use get_component to find the component on the current game object and assign it to anim. So anim equals get_component. And it's going to be the type of component we're looking for is an animator. There we go. So when the game starts and our object calls the start function, or Unity calls our start function, the get_component method will look inside of this game object and it will go through transform, no that's not it, sprite renderer, no that's not it, animator, that's what we're looking for, and it will take a reference to this and store it inside of the anim variable. Now that we have a reference to the anim variable, in the update function, we can deal with our inputs. So what I'll do is I'll create two floats, one called input x and one called input y to store the input. I'll just simply say float input x. It's going to be equal to input.get axis raw, because we want the raw information of the axis. What raw does is it returns you, if you're using a keyboard and you press left, it will return the number 1. If you're not pressing left, it will return the number 0. If you just used get axis, what happens is when you press 1, it slowly goes from 0 to 1. So it goes 0, 0.2, 0.4, 0.8, 0.9, 1. And what you get is the effect of, say, someone using a gamepad. You get a much smoother input. However, since we're dealing with an RPG style game here, I want a raw input. And that's going to be the horizontal axis. Horizontal. Then we'll do the same thing for our y input. I'm going to say for the y input, it's the vertical axis. There we go. And now we have our inputs. The next thing we need to do is determine if the player is walking. And we can do this simply by, first of all, if you understand that when you push left, it's going to be -1, and when you push right, it's going to be 1 for the input x. Now, if we use the absolute function, which is usually part of every single math library you'll ever find, that will take a negative number and make it positive. So if the number was -1, it will become 1. We can take advantage of this by saying bool is walking. So this is going to be the variable we use to store this. And then what we'll do is we'll do a simple calculation, which will just be mathf for floating point mathematics, abs, which is the absolute function, input x, there we go, plus mathf.abs, and we'll be using input y. Now what we've essentially done here is we've taken the, I'll just put a semicolon on the end there, for that's not going to solve the problem, but this is erroring at the moment because we're not finished with this. But basically what we've done here is we've said whatever input x is, if it's below 0, i.e. if it's -1, make it 1. And that way this will become 1. Now, if you're not pressing up or down, this is 0. And what happens is this entire statement here says 1, which means, yes, we are moving. Because if you think about a Boolean value, 0 and 1, true and false, 1 means true. And true means we are walking in the context of is walking equals true. If you weren't pressing anything, these would both be 0. If you were pressing right, this would be 1. And this would be 0, and it would be 1. Now, if this is 1 and this is 1, it's going to be 2. So that's not going to work because we can only have a 0 and a 1 for this. So what we need to do is a very simple calculation. If we say if this is greater than 0, we're going to do an inline if statement here. If the result of this is greater than 0, we are moving. And C# is going to take this as an if statement and return this as a true or false, because this now becomes a conditional statement. If this is 1, if this is greater than 0, then this entire string here gets replaced with true. If it's not greater than 0, that entire line gets replaced with false. And you see how that works? We are determining whether the player is walking based on the input x and y. From this point, we can say something like if is walking. So if the player is walking, then what we need to do is we can set the x and y on our animation controller. Now, if we go back to Unity for a second, and we look at our animator or our animation controller, you see it has this parameter x and parameter y. What we're basically going to say here is we're going to say that those two variables are whatever our input was. And we do this by saying anim.setFloat, because they were floating point numbers, if you remember. We're going to say x is our key, and the value is going to be input x. There we go. So we're basically saying if the player is walking, then go and push this value into our animation controller. So this will be changed from 0 to whatever the value is, be it 0, +1 or -1. We're going to do the same thing for y. So I'm going to say y. There we go. And the other thing I'm going to do is I'm going to do one more. I'm going to set that is walking variable just up above the if statement here. anim.setBool, because it was a Boolean value. If you remember, this is a true or false. The key for that is walking with a capital W. And the value is going to be the result of our calculation, which was this line here. That was this line here. So what happens is we are moving. Let's say this is true, for instance. We say is walking is true. Now, if we look at our animation controller, you'll see that our idle states transition condition is that is walking is true. So as soon as we start walking, then the animation controller will move from the idle state to the walking state. Then when we let go of a direction, up, down, left, or right, or W, S, A, and D, then it will transition back from walking into the idle state. And yes, you can play different animations in the idle state. I've just chosen to go with a static image so that the player is not moving. And finally, just to demonstrate that this is actually working, I will adjust the position of the player by saying transform.position, remembering that this game object, be the player, has a transform component attached to it, which deals with positional data, rotation, and scale. So we're going to deal with the position. We're going to use the shorthand plus equals, which basically means I want it to be equal to what it was plus the value that I'm about to specify. And that value is going to be new vector 3, because it is, even though we're dealing with a 2D game here, position on a transform is still a vector 3, which means it has an X, a Y, and a Z value. We're going to say new vector 3. It's going to be input X, input Y for the second parameter, and for the third parameter Z, we're going to use 0. Now finally, we need to normalize this, so we'll say normalized, and I'll explain what normalized means in 2 seconds. And then we say multiply this by time.delta time. Now let me explain quickly what normalized means, and I'll do that by opening Paint up. There we go. I'll just open Paint up. Now if you imagine some Cartesian coordinates, for instance, I'm just going to draw a little plus like this. This is going to be a terrible example. And let's say that this was like 1 and this was 1. Oh, sorry, that'd be 0 actually. That'd be -1. This would be, that'd be 1 and that'd be -1, like that. Negative, oh, I can't put that last one in there, -1. So left, right, up, and down. If the player was pressing right, it would be X equals 1. If the player was pressing up, it would be Y equals -1. But what happens if the player is pressing both of them? Now, if we took a ruler and measured this line here, which I'm going to highlight in red, what you'd see is this is actually going to be longer than this line and this line, and we can tell that it's longer by drawing a smooth-ish curve. I'm going to try to get this as curvy as I can. That was terrible. You know what? That was absolutely terrible. Bad effort. I'll just draw a circle. There we go. You can tell it's longer by drawing a circle because from, oh my gosh, what am I doing? There we go. Because if I draw a circle from here to here, then from this point to this point would be the right length. But you see we have this extra bit coming off the end here. So essentially what happens is if the player is pressing up and right, they'll move slightly faster. So we call the normalized function on the vector 3, which returns us a value between 0 and 1 all the time. It makes sure that those values do not go above 1, basically. In this context. In other contexts, it will go above 1, but we'll talk about that in another video. And finally, we multiply this this vector 3 by time.delta time, which is the time between frames. If we didn't do this, we would be moving at a ridiculous speed, and I can demonstrate what that speed is simply by leaving this as it is, going back to Unity and pressing play. There we go. And if I move, you see our player is just gone. That's because we're moving not relative to the speed of the game. We're moving, we're just moving as fast as the player presses. We're moving 1, like infinite times per frame. So we need to multiply this by time.delta time, which basically is the time between each frame. And by doing that, we start moving in frame time rather than in your own. Oh, no we don't. No we don't. Oh, what's going on there? You know what I did? I didn't save the script. My apologies. Save the script. Back to Unity. Replay the game, and now I'll move. There we go. So now you see that we're moving in frame time. Now see I've got the up and down the wrong way around. The good thing about doing it this way is that it's super simple to change these animations. You just go into the blend tree, load up your animation from your player anim folder, and then just replace up with down and down with up. There we go. Did I do that right? Yes, I did. I don't know why it's looking down now. Because, sorry, my bad. Because the other one, the idle animation, has the same thing. Slight bug there. There we go. Replace down with up, idle, and then down idle becomes... There we go. I just had the animations the wrong way around. That should solve the problem. There we go. And now you see that we have this very simple, I mean, some might say it's more complicated. However, if you look at our code, we never had to deal with frames. We never dealt with the index of the frame. We didn't have to deal with changing the sprite out and doing, you know, working out what state the player's in to change the animation and things like that. The beauty of doing it this way is that while what we have here is a very simple example of moving up, down, left, and right, you can see that this can be expanded into many other things. Like right now we have an idle and a walking blend tree. You could add new states, for instance, you know, attacking, attack, for instance, and you'd have a transition from either idle or walking to attack. And then from attack, you might have a second state, for instance, super attack, which you can only get to from having attacked once using a normal attack in the first place, if that makes sense. So this is a way of allowing you a very flexible option in doing your animation within Unity for 2D. Now this works with 3D as well, but I'm showing you in the context of 2D because I wasn't able to find many people doing 2D tutorials on Unity. Now one thing you'll see is the animation is probably a little bit too fast. We can click on the walking blend tree and we can adjust the speed of that. We can make that 0.3. I'm going to make that 0.3. There we go. And now you'll see that our animations have slowed down. Now the other thing you'll notice is the time it takes to go between these two animation states. We can make that instant as well simply by clicking on these and shortening the time it takes to go between animation states. This is pretty cool. There we go. So now you'll see that I'm instantly transported between the two animation states. And you can actually see the way that it's working. As soon as I press left, the isWalking variable gets set to true and x is -1. Well, if I let go of left, it turns off and x stays at -1 so that I'm facing left. If I press right, you'll see that x now becomes 1 and isWalking is enabled. If I let go, x stays at 1. And this basically means that we stay facing the direction that we last pressed, and that's got something to do with the fact that we only update those x and y variables when the player is walking. As soon as you let go of those keys, we're not walking anymore and it doesn't reset the animation. Now something else I'll demonstrate real quick, the power of using abstracted concepts. So this get axis raw, horizontal, and vertical. We didn't specify which button we were pressing. We didn't specify that we were looking at the left key or the A key in W, S, A, and D, or a gamepad's left or a joystick's left. All we specified is that we wanted the left or the horizontal axis basically. Now in Unity, something pretty cool. If you go to Edit, Project Settings, and Input, and then you can open up this axes, you'll see horizontal here. Horizontal is actually defined as many different things. It's defined as the left key, it's defined as A from W, S, A, and D. It's also defined as the X axis on a joystick. And you can change these as you feel for your game to actually run. You can add more or less of them. But the interesting thing here is if I turn on my Xbox 360 gamepad and I start pressing, or I'm just moving the stick around, but basically you can see I'm able to walk with my gamepad, I'm able to walk with the arrow keys on my keyboard, I'm able to walk with W, S, A, and D on my keyboard, and we got all of this functionality inherently from Unity because we did it using this get axis raw function instead of programmatically saying if keyboard pressed key.left equals true and then doing 5 different if statements and things like that. So this is actually a very efficient way of doing your animation. Just to reiterate what I said earlier, I think I can make it sound more clear. If you consider a game like Monster Hunter, where you have different types of attacks and you can do them only after doing certain types of attacks, this state machine will allow you to keep track of that without having to write a single line of code, because you would simply make transitions between walking and attacking, or idle and attacking, and then from attacking to the next level of attacking, whether that's, initiating your second level attack, which is, you got your first attack, which is a little jab, and your second attack is maybe like a spinning slash or something like that. So the animation controller is very useful in that sense. Finally, the other thing an animation controller can be used for is these animations and states of animation can be retargeted to other players. So for instance, if you had multiple players in your scene and they all used the same frame structure, you can retarget these animations to other sprites, as long as they're using the same animation structure. And it's not just the animation, it's also the state. If you have animations for attacking, defending, getting hit, rolling on the floor, things of that nature, then you can reuse all of this logic without having to write it differently for those different creatures. So for instance, an enemy might reuse the same animation states that your player uses for, attacking, defending, taking damage, and even possibly death and things like that. So this is the first in many to come Unity tutorials. I will be covering 2D and 3D. I hope you've enjoyed this. If you did enjoy it, please leave a like. That really does help. Also, I'll be uploading the files for this tutorial to my blog, which I'll leave a description in the... I'll leave a download link in the description below the video. And yeah, I'll catch up with you guys next time. Hope you've enjoyed this. Bye for now.